Good evening, everyone. Good evening, friends. Welcome back to our sessions on Python for AI. So, we are just a step ahead of completing this particular program. Okay, so there are four more steps under data pre-processing. We are going to learn all these four steps in today's session, and then we'll be discussing about the program. Right. So, we started understanding data pre-processing. Data pre-processing is nothing but data cleaning. What are we doing here? We are cleaning the data, right? What are the different names, different other names given to data pre-processing? It is also called as data munging, data wrangling, data organizing. So all of these are different names for data pre-processing where we clean the data. This is one of the essential steps that we have to perform before we prepare the data to build the model. In order to build a model in this fashion, we are going to clean our data. So in total, how many steps do we have under data pre-processing? There are 9 steps. What are they? Typecasting, handling duplicates, outlier treatment, zero and near zero variance, discretization, dummy variables or feature encoding, handling duplicates, handling missing values, transformations, and feature scaling or feature shrinking. Yes. So out of the 9 steps, we have understood 5 steps. So today, we are going to learn the rest of the 4 steps. And all these 4 steps are very important, guys. Pay attention. Okay. If you find any difficulty, if you are unable to cope up, if you get any kind of questions, keep them in the chat. I'll be answering all your questions. Right. So let me start with the 6th step under data pre-processing. It is called as dummy variables or feature encoding. What it is? It is called as dummy variables or feature encoding. We know what is a variable. We know what is a feature. What are variables or features? Guys, what are variables or features in data? Variables are features. Both of them, they represent columns. Columns are also called as features. Columns are also called as variables. So, what am I doing? I'm going to come up with dummy columns, dummy variables, or we are encoding the columns. But why should I encode the columns? Or why should I create dummy columns, dummy variables? I'll come up with a scenario, guys. In our data, we'll have both numeric columns and non-numeric columns. Am I right? Yes. Not every time we'll just have only numeric columns. Or every time we'll have non-numeric columns. Right? In general, the data that we work on will be mixed data. It will be mixed data. So on this mixed data, if I build a model, an ML model or DL model, machine learning or deep learning model, which helps us to predict the data, the future data. Anyhow, numeric columns, the numeric features can be included in this equation. But what about non-numeric columns? What about non-numeric columns? Non-numeric columns, can I directly include them in the equation? No. Why? How can non-numeric columns, non-numeric values can be included in an equation, in a mathematical equation? We cannot, right? We can't do it. For that reason, if you feel that this non-numeric column is important, that it has to be included in this equation, we create dummy column. We create dummy variable. So this will be our original, and we are going to create what? A dummy column for this original column. Okay, that is what we do in this step. Dummy variables are feature encoding. We are encoding the features. So in short, what we do here, in dummy variables or feature encoding, we convert non-numerical data to numerical data. Yeah, non-numerical data, non-numeric column will be converted to numeric column. It is a dummy column, right? Yes, this is what we do. I'll give good examples, and this can be done in two different ways. Okay, we have one hot encoding and label encoding, guys. We have two techniques to get this done. To convert non-numeric data to numeric data, we have one hot encoding and label encoding, two different techniques. So let us understand the techniques that are available. I'm going to take the same dataset, cars dataset, and let me continue with the use case. What am I doing? I'm importing pandas as PD. Importing pandas as PD for data manipulation. For manipulating the data, we are importing pandas. Since the data is available in an Excel file, we are using read underscore Excel function from pandas. I'm using read underscore Excel function to read the data from an Excel file, and this data gets stored in an object, a variable called df. Let me do it. So df is the data frame of size 428 rows and 14 columns. Done. Then what are we doing in the next step? Line number 297. I'm going to use drop function. I'm using drop function, and what columns am I dropping? Make and model. Make and model are two columns which are non-numeric. Non-numeric columns which are not important. Okay, so I'm going to drop the two columns, and I'm specifying these are columns. How? Using the parameter axis. Axis is equals to 1 represents columns. Axis is equal to 1 represents columns. Yes, we are dropping the columns from the data frame df. So what will be the size? 428, 12. So this will be stored in df1. The output will be stored in df1. So what will be the size of df1? df1 will be of size 428 records, 12 columns. Next to it, what makes the difference? Both the steps are seen. In both the steps, we are dropping the column, make and model. But additionally, what do you observe the differences? Axis is equal to 1, which represents columns. But in place operation, line number 300 performs in place operation. That means within the same object, within df, two columns make and model gets dropped. Why? Because this is an in place operation. But here, is this an in place operation? No. Even though if you execute this line, df will still contain 14 columns. But df1 will contain 12 columns. There is a lot of difference. Okay, so let me execute the code till here, guys. We have read the data. Now I'm going to drop the columns and I'm not performing any in-place operation. Let me see what will be the results. You see df1 size is 428, 12. For line number 300, I'm going with in-place operation. So df size will automatically reduce by 2 columns. It will be 428, 12. I hope it's clear. Yes. Now, I'm going with get dummies function. I'm going with get dummies function. What is this get dummies? Get dummies is the function that is available in pandas, which helps us to get the dummy columns for non-numeric columns. First of all, what all columns did we have? There are 12 columns, out of which 9 are numeric, 3 are non-numeric. What are the 3 non-numeric columns that we have? Type, origin, drivetrain. Type, origin, drivetrain. So, obviously, get dummies work on the 3 columns or the 9 columns? The 3 columns. You are going to what? You are going to build dummy columns. So, you will be generating the dummy columns for the first 3 columns only, for the non-numeric columns. Just give me a minute. Right. Now let us understand. Anyways, I have to perform from here. Pandas, then reading the data, dropping the columns that are not required. Yes. Now let me use get dummies to build the dummy columns. Okay, so this get dummies is a function that is available in pandas. But before that, we have to understand, right, how this get dummies work. Okay, so what I'm going to do is I'll explain you how get dummies will work, guys. Assume there is a column called gender. There is a column called gender. And in gender, what kind of values you can expect? Female, male. Female, male. So on. Yes. So when you perform get dummies on this column like gender, initially it checks for how many unique categories that are present in this column. How many categories do we have? Two categories. So it comes up with two dummy columns, gender underscore female, gender underscore male. See, this is before encoding and this is after encoding. Before performing get dummies, after performing get dummies. Then, depending on the value, the original value, it assigns the value here. Here it is false, right? So under the gender underscore female column, it gives 1. For rest of all the values, all the column values, it will be 0. It goes to the second record. It is male. So here it will be 0. Under gender underscore male column, it will be 1. So what's happening? A non-numeric column is getting converted to numeric columns. Can I use it in the equation? Yes. That is called as, dummy variable creation, feature encoding, so on. This is what happens, guys. That's it. So what you can understand is a non-numeric column like gender is getting converted to numeric column. But how many numeric columns? It depends on number of categories. Number of categories present in that specific non-numeric column. If there are 2, you'll get two numeric columns. If there are 5, we'll get 5 numeric columns. But every time will it be gender underscore female first or gender underscore male first? Every time it will be gender underscore female column first. Why? Alphabetically, females come first. I hope it's clear. So the first column that we'll get is gender underscore female, not male, guys. Okay, I'm not biased to any word gender because this is how get dummies or one hot encoding works. Then what about the values? Values will always be 0 and 1 only. In either get dummies or one hot encoding, the values will be only 0 and 1. There will not be any change with respect to the values. No. Okay. Now, let me do it on the data. What am I doing? pd dot get underscore dummies. So this is the function from pandas. From pandas, I'm using the function called get underscore dummies. What am I passing? I'm passing the entire data frame df on which the 9 columns, the last 9 columns will be as is, but the first 3 non-numeric columns will be converted to numeric columns depending on the categories that are present in each and every column. See, let me give a try. And where is the results getting stored? The results will be stored in df underscore new. Let me do it. You see the size? What is the size? 428 comma 21. 21 columns. From 12 we got 21. That means what I can understand. I know this 12 is nothing but 3 plus 9. 3 non-numeric, 9 numeric. So which will be 12 plus 9? Because this 9 will not change. When I use dummy columns, when we are going to build dummy columns, feature encoding, the numeric columns will not change. Non-numeric columns will change. So 3 columns got converted to 12 columns. Let us understand the output, guys. Yes. So these are the first 9 columns, the numeric columns. I'll ignore these. Let me go to the 10th column. Type underscore hybrid. So the first non-numeric column that we have in the original data is type. See, type is the first non-numeric column. So obviously type underscore hybrid comes first because H. Next to it, type underscore SUV. Since the first value is SUV, you'll find 1 under SUV. Rest of all the values will be 0 till type. Type underscore sedan. Type underscore sports. Type underscore truck. Type underscore wagon. So how many columns do you observe for type itself? 6 columns? Yes. One column got converted to 6 columns. In the same way, next one is origin. Origin Asia. Origin Europe. Origin USA. So one column got converted to 3. And drivetrain, in the same way, it got converted to 3. Drivetrain all, drivetrain front, drivetrain rear. So the result is like this. How did I get this 12? There is a column called type and this got converted to 6 columns. The next one is origin and this got converted to 3. The next one is drivetrain. This also got converted to 3. 6 plus 3 plus 3, 12. So what happened? I used get dummies function from pandas which helped me to convert non-numeric data to numeric data. Yeah, non-numeric data got converted to numeric. So all these 21 columns are numeric. But hold on. Hold on. You see the number of columns getting increased? Yes. Can you reduce the number of columns anyhow? Yes, I can. How can I reduce the columns? Is by dropping the first column of each and every dummy column category, I can at least reduce 1 column per the original non-numeric column. See the same code, but additionally, what do you see? An additional parameter called drop underscore first. Drop underscore first parameter will help us to drop the first column, the first encoded column, as it will reduce the dimension. Even though if I drop the first column, still I can have the data intact. Still I can understand the original values by using the rest of the values. That is the purpose of drop underscore first parameter. So if I use drop underscore first, the dataset dimension will be 1 will be removed from here, 1 column will be removed from here, 1 column will be removed from here. So 1, 1, 1, that means 3. 3 columns will be removed from 21. The output will be 428, 18, guys. Let me execute. You see, df underscore new underscore 1, same data. There is no change with respect to the data, but the number of columns were being reduced. Obviously, we want to work on less number of columns, right? We don't want to complicate ourselves. Then Either you work on these 21 columns or 18 columns, both are same. Both represent the same. Is it clear? Yes. In the same way, we have, like get dummies, we have one hot encoder, guys. But there is a small difference between get dummies and one hot encoder also. Okay. So df dot columns will return as the column names. It will return the column names present in the data frame df. So these are the list of columns that we have. All the 12 columns. Now, what am I doing? I'm importing one hot encoder from sklearn.preprocessing. From sklearn package, preprocessing, I'm importing one hot encoder. Let me do it. What is the purpose of one hot encoder? It helps us to perform one hot encoding. What is one hot encoding? Whatever we have discussed just now, the get dummies, whatever it performs, in the same way one hot encoder works. So I'm initializing one hot encoder. See, I'm initializing where I don't want to get any sparse output. I just kept the sparse output as false, and I'm going to initialize one hot encoder to an object enc. Done. Initialized. So this enc, which is nothing but one hot encoder, will be used on, what is this? I'm making one hot encoder to fit on the data. You see here, df.iloc. I'm accessing a part of my data from the data frame, iloc of colon, which means all rows, comma, 0 colon 3, which means column 0, index column 0, index column 1, index column 2. The first 3 columns. So one hot encoder works on only the non-numeric columns. Right? Yes. Then this will return as the column names, not like get underscore dummies. Get underscore dummies, as it is a function from pandas, you just need to pass the data. That's it. If you pass the data, encoding will be done. But here, this will not return as the column names. In order to get the column names, what am I doing? I'm using the columns of the first 3. Okay. And that will be utilized by one hot encoder to get the feature underscore names underscore out. So this will return as the column names, and these column names will be given to the encoded columns. And the output will be an array, guys. It will be an array. That array object we are converting back to data frame. Data frame is a function which is available in pandas. So the final output will be a data frame object which gets stored to enc underscore df. See, the output will be same. The output will not change. You compare the output between get underscore dummies and one hot encoder, you will find the same output. How many columns it gave? 12 columns. Earlier, this also gave me 12 columns. Right? Yes. Next to it, what am I doing? So encoding was done. Post encoding, I'm going to concat the values. What values? The data frame that we have got, and within the original data frame, I'm going to access only the values of the columns of numeric. I'm taking the numeric columns and the encoded columns and I'm combining them. I'm performing concatenation and we are able to concatenate based on columns. Based on columns. So this will return me how many columns? In total, the output will be 21 columns, guys. I can still remove here 3 columns. The first column from each and every category can be dropped. That is not required. Right? Yes. So that is how one hot encoder works. Now let me go and explain label encoding. One hot encoder, it is clear, right? But label encoding is generally used on output column or target column. What is the purpose of label encoding? To build a dummy column again. But it is very simple compared to one hot encoding because the output of label encoding will be again only one column. For example, if you have a column like gender in which we'll have male, female, male, male, female. So only these kind of values you can have, right? And if you apply one label encoding on this data, what happens? Label underscore gender. Okay, even though if the column has, if the non-numeric column has 2 or n number of categories, the output column will just be only one. How many output columns can you expect? Only one. Not like one hot encoder or get underscore dummies. Okay, so the conversion will start. Label encoding is generally done on ordinal data guys. Okay, based on their order, we rank. But anyhow, we cannot order these genders, right? So alphabetically, we give the values. Male will take 1, female takes 0. 1, 1, 0. This is nothing but the output of label encoding. Clear? One hot encoding and label encoding. The differences. Right. Now let me apply label encoding on the dataset. For that we have to import from the same sklearn.preprocessing. I am going to import label encoder. What am I going to do? I am going to import label encoder. Then this label encoder that was imported, we are going to initialize it. The label encoder gets initialized. Done. Now, this label encoder, we are going to fit on drivetrain column. So within the data frame DF, I'm going to use it on the drivetrain column. So the label encoder gets fitted and it will also return me the transformed results. Where are the transformed results getting stored? They are getting stored in the same data frame in a new column drivetrain underscore ENC. Let us have a look. See, this is your drivetrain and these are your values. For all, it is 0 alphabetically. For friend, it is 1. Rear it is 2. Is it clear? Yes. In the same way, let me also use label encoder on the type column. We also have type, right, in which there are 6 categories, 6 different types. So the label encoder gets fitted and it will also return the transformed results. These transformed results get stored to a new column within the same data frame, type underscore enc. So let me open the data frame. See, you will have it from 0 till 5. 1, then 2, 3, 4, and 5. So in total, the 6 categories. How are they marked? They are marked based on the alphabetical order. That's it. And every time for label encoder, you can just expect only one column as output, guys. Only one column will be given as output. Yes. So with this, we mark the end of dummy variable or feature encoding. What we exactly do in dummy variable creation is we are going to create dummy variables. Nothing but we convert non-numeric data to numeric data. That's it. Non-numeric data will be converted to numeric data. That is what we do in dummy variable creation. Dummy variables, dummy columns get created. Right? Yes. So let me handle the missing values. The next step that we have is missing values handling. In general, we may have missing values, right? There might be multiple reasons behind it. Okay. Some in some cases because of humans, whoever is going to enter the data manually, or as a part of a survey, if the person is not going to disclose their details, so there we'll find the missing values. And because of these missing values, again, the model performance will be affected negatively. So for that reason, we are going to handle the missing values with a method called imputation. Okay, so I'll talk about imputation, guys. First of all, imputation is nothing but, you are going to replace with something. Wherever you have an empty cell, you are performing imputation, right? So let me, yes. Let me initially import the necessary packages. NumPy as NP. What is the purpose of NumPy? For basic mathematical calculations. Then pandas as PD. Why pandas? For data manipulation. Right. Next to it, I'm going to read the data, the same data, but we have customized the data in which we have null values, and this data we are going to read and store it in our data frame. It is that object will be df. Df is the object name, 428 rows and 14 columns. Info function will return as the data set information. This is going to return the data set information. The number of columns, the number of rows, column names, And do you see null values? Yes, I see null values. I see null values. 424 non-null means 4 of them are null. So in this way, if I observe, there are null values. There are null values. So I have to handle the missing values, the null values. Right. Before that, let me print a message getting the count of the missing values in each column. For that, I am using the logic as df dot isNA is a function which will check each and every cell within the data frame df, and it checks whether the cell is occupied with a value or null. Okay, if it is occupied with a value, it returns false. If it is not occupied, it returns true. isNA. So all these Boolean values get summed up to get the overall count of missing values in all the columns. See, coming from the starting, I see 3 missing values in drivetrain column, 4 in MSRP, 7 in MPG city, and 3 in weight column. There are missing values, guys. So for that, we use a function from sklearn. It is called as simple imputed. What it is? Simple imputed. From sklearn.impute, we are going to import simple imputed, which helps us to perform imputation. Done. Then I am initializing the simple imputed. Okay, I am going to initialize the simple imputed where I am going to keep the missing values as np.nan. If there are any missing values, so there the strategy mean has to be applied. So with the mean value, we are going to impute the values. We are going to impute the missing values with the mean of that particular column, the mean value of that particular column. But when is this accepted? When any column which does not has outliers. Why? If it has outliers, mean value gets influenced. Mean gets influenced because of the outliers, and strategy cannot be mean. We have to go for median. So let me initialize simple imputed. Where did we store the results? We have assigned it to mean underscore imputed. Yes. This mean underscore imputed will now be used to fit on the column. What column am I taking? MTG underscore city. The simple imputed with the strategy mean gets fitted on the data, and it will also return me the transformed results. It will return me the transformed results, and these transformed results will be stored in the df data frame within the same column mpg underscore city. So imputation will be done, okay, with the mean value, and the results will be stored in the same column. Let me do it. Is it done? Yes. Now I'll go and check whether there are any null values. Still, if there are any missing values in the same column, because we applied simple imputer, right? Let me check. So the output you see here, it is 0, guys. No missing values, nothing. In the same way, can I also go with median imputation? Yes. I'll just change the strategy to median. But when is this used? In general, median imputation is used when the column contains null values And if the column is numeric, if it is a numeric column which has outliers, extreme values, there we initialize simple embedder with the strategy as median, and that median embedder will help us to fit on the data like MSRP column. I'm going to fit on the column MSRP. So here the imputation will be done and the results will be stored back to the same column again. Again, we are going to cross check the results. We are going to cross check the results whether there are any missing values in the same column or not. So the output should come as 0, guys. If you get any number, that means you did not work in a right way. You have to do it again. The output obviously should be 0 when you are cross validating. Next to it, we have mode imputation. So just change the strategy to most frequent. Mean, median, most frequent. So when is this generally used? When you want to impute any value, when you want to perform imputation in non-numeric columns, then we generally go with the most frequent, nothing but mode imputation. We go with mode imputation. Right. This mode imputer, I'm going to fit on the drivetrain column. We know that drivetrain has missing values. Yes. So I'm going to fit on the drivetrain column. And I'll get the transformed results. These transformed results will be stored back to the same original column. Yes. So I'm done. I'm cross-validating the results. I'm cross-checking whether I have the missing values still in drivetrain. No, it is 0. We also have constant imputation, guys. We also have constant value imputation. The strategy you should mark it as constant, and the value that you would like to pass as a constant should also be defined upfront. This is called constant imputation. When you don't want to go with mean, median, mode, then you can go with constant imputation. So this value that you have gets imputed wherever there is a missing value. This is called constant imputation. What is it? 3500. Now, I'm going to use this constant imputer. I'll fit it on the weight column. I'll get the transformed results. These transformed results are also stored to the same column again. Done. It's done. Now I'm going to cross check the results of the constant imputation. df of weight dot is null dot sum. So I'm going to check whether there are any missing values still after performing imputation. No. No missing values. And finally, I'm going to perform info function once again to check whether there are any missing values in the data. Let me do it. I don't see any kind of missing values. Now I just went with a constant. That is what constant imputation means. Okay. Again, see, to which column am I doing? This 3500, I took it as a constant and I'm going to impute in which column? Weight. So this value that you are going to take as a constant for imputation should be decided based on the column that you are going to perform the imputation. Okay, since the car weight, it cannot be single digits, right? in general. So depending on the rest of the values, I took a close value, and that value as a constant I'm taking and I'm performing imputation. This is just a constant. But when it comes to real time, what you have to do is this value should also make some sense, right? When you are defining a constant value, ensure that it is making some sense. You are performing imputation. Assume that there are missing values in salaries column. Assume. Okay. And if you are going with constant imputation, can you take the fill value as 10 rupees? 10? It doesn't make any sense. Can salary be 10? What is 10? So that is what. When you are going to define the constant imputation, ensure that the value makes some sense. If not, there is no use. Is it clear now? Yes. So what did we do? We handled missing values. Missing values should be handled. In general, the best and the easiest way is imputation. We impute the values, and under imputation there are multiple strategies. Mean, median, mode, constant. Okay. Still there are multiple guys. So when do we generally go with mean imputation? Mean imputation is applied when the column is numeric, because mean cannot be calculated for non-numeric data, right? So the column should be numeric and the column should not contain outliers, extreme values. But if you go with median imputation, again, it should be numeric in nature and it can also have outliers. Even though if there are outliers, still median value can be imputed. Mode, especially for non-numeric data, for imputation. And finally, constant, it depends. It can be useful for numeric and non-numeric. But the fill out value should make some sense. That's it. Let us go to the next step, that is transformations. What is the next step? Transformations. What do you mean by transformations, guys? What do you mean by the word transformations? Transformation, yes. So the next step is transformations. What exactly we do in transformation is, yes, changing the form. It's nothing but change, modifying. But what are we modifying? What are we changing? Is we generally check for the normality of the data. We check for data is normally distributed or not. Data is normally distributed or not. If it is, how can we come to know whether it is normally distributed? Is there is a plot called QQ plot, quantile plot called, we have discussed, right? Under data visualizations, did we discuss QQ plot, quantile plot? Yes. So there is a plot called quantile plot, or also called as QQ plot, which helps us to plot the theoretical quantiles and sample quantiles. I'll show you the graph, the plots and all. So the purpose of this plot is, you know, it helps us to check the normality of the data. Whether the data is normally distributed or not, we'll come to know by visualizing this QQ plot. Okay, if the data is not normally distributed, then we do transformations. Why? To convert the non-normal data to normal data. To convert, to modify the non-normal data to normally distributed data. That is the why do we use transformations? The purpose. Is it clear now? So for that we have to understand what is this QQ plot, how it is interpreted, how it is understand. Okay. Then how the transformations, the different types of transformations that we have, everything we are going to understand. Hold on. Right. So I'm going to import pandas for data manipulation, NumPy for basic mathematical calculations, scipy.stats. From scipy, I am importing a module called stats as stats. Even the alias name is also provided as stats. So scipy for advanced calculations, pylab for visualization. Seaborn is also for visualization, and matplotlib.pyplot is also for visualization. See, I'm going to read the data from an Excel file. So this is our Excel file path. So to read the data from an Excel file, we use function called read underscore Excel from pandas. From pandas. And the data gets stored to df. Df will be the variable to which the data gets stored. 428 rows, 14 columns. The same data, guys. There is no change. Let us visualize QQ plot first of all. What is this QQ plot? We'll understand. From stats, scipy.stats, there is a function called propplot. There is a function called propplot. So this propplot function will generate a QQ plot on which column? MSRP. df.msrp. Manufacturer suggested retail price. Okay, so on this column, I'm going to plot a QQ plot. The distribution that I want to check is not normal distribution, and the plot that I'm going to consider is pylab. So let me execute this. See. You see on the x-axis theoretical quantiles, which represent z values. On the y-axis, you will observe ordered values. Sample quantiles, which are nothing but x. What is x here? MSRP. Manufacturer suggested retail price on the y-axis and the z values on x-axis. What is z? Z is nothing but standard normal distributed curve. This is the normal distributed curve, which is universal standard. Okay. So now let us understand whether this MSRP data is uniformly distributed, it is normally distributed or non-normally distributed. You see this red line? The data points that you have, they have to pass, majority of these points have to pass from this red line. Do you observe that? Not exactly, right? It is not purely normal, but partially, because they are close here. So, how to interpret probability plot? Nothing but QQ plot is, you'll be observing a line through which the scatter point should pass through. Majority of these points should pass through this red line. Then we see the data is normally distributed. If not, non-normally distributed. They are not normally distributed. No. So let me show you few more examples. The same code, but which column it is? It is weight column. I am going to visualize QQ plot on weight column. You see here? This time, yes, under weight, it is better than MSRP. Because at the ending, at the starting, I see the values are, the scatter is away from the red line, but majority of these are better. Yes, comparatively better. So that means data is non-normal case. If you take column like MSRP, data is non-normal. If the data is non-normal, what we do? We use the concept of transformations. We use the concept of transformations. What does transformations does? Is transformations help us to convert the data from non-normal to normal. A few transformations that were listed down here. You see, I'm going to get again a QQ plot on which column? MSRP. But are you taking the same values as it is? No. You are going to get the square of the values. So this is a transformation. Some of the transformations that I am writing here. Square, cube, square root, cube root, reciprocal, log, exponential, so on. So, if you apply any of these transformations, what happens? Here you took the values as is. But here, I'm not going to take the values as is. Each and every value of MSRP will undergo with this square transformation. So each value will be squared. If you have x, it returns you x square. If you have x square, it will return you x power 4. So on these values, you will be visualizing QQ plot. That is called transformation. Okay, now let me check. Again, this is an experiment, guys. No one can tell this. Which transformation will work for which kind of data? You see, earlier it is in this way, now it got changed, the direction and all. Yes, I'm going with square transformation, but still I see the same. There is no change. Next to it, again we are using square transformation, but this time on the weight column. Wow, it's still the same. There is no change. Even the weight column is also, it is not normally distributed. When I go with transformation, it did not convert the data to normally distributed. So probably we can understand that square transformation is not allowing us to fit on this data. No. So it is like experiment. No one can tell that. We have to experiment all the different types of transformations that are available. If not, we can go with automated steps. I'll tell you. So we experimented with square. Yes. Now let me go with log. NP dot square. NP is numpy and square is a function from numpy. In the same way, log is the function. Log is the function. I'm going to apply log transformation. Log function from numpy. So I'm going to take the log of values for MSRP and I'm going to visualize the QQ plot. Now you see what happened? Is it normally distributed or not? What do you say, guys? When we have applied log transformation on the data MSRP, what do you see? Is it normally distributed or non-normal still? Yes, it is. It is normally distributed. You see, from here till here, even the values are close here. So the values got transformed. When? So log transformation worked for MSRP. Log transformation worked for MSRP column. In the same way, what are we doing? I'm applying log on weight also. On the weight column, I'm applying log transformation. Let me check. Will it work or not? Wow, perfect. For weight column, it gave me perfectly normally distributed data. Yes. So this is the output of log transformation. So I can understand that log has given us the right results. It transformed the results. Right? The log transformation gave us the best results. But if you have a question like how many experiments should I perform? Okay, if you don't want to waste of your time, then you can also go with techniques like Box-Cox transformation or Yo-Johnson transformation. There are two automated transformation techniques. One is called Box-Cox transformation. What is this Box-Cox transformation? It's nothing but it uses the formula as y power lambda. It tries with different values for lambda and it gives you the best transformed results. So this is an automated technique, guys, Box-Cox. But the challenge with Box-Cox is the entire data should be positive. All the values present in the data should be positive. If you pass any negative values, if you are trying to use Box-Cox on any negative data, it will not give you the results properly. The challenge with Box-Cox transformation. See, if you see, I'm going to use Box-Cox stat scipy dot stats dot Box-Cox. Then on which column am I using? MSRP from data frame. MSRP is the column that I am using. Manufacturer suggested retail price. We know price cannot be negative. So let me use box cocks on MSRP. So this will try multiple experiments in the backend and it will give us the best fitted lambda, the best lambda value and the fitted data for it. See, done. So this is the best fitted lambda. Yes, the drawback challenge with box cocks is all the values should be positive. And this is the fitted data. For which column? MSRP column. For this lambda, these are the values. Now, let me visualize the difference between, before applying box cocks and after applying box cocks. For that, I'll initially get the visualization, then we'll understand this. So, what do you understand from here? This is MSRP original data. That means before box cocks. How is the data? The data is see like it is right skewed. Yes, because a long tail towards right hand side. It is right skewed. It is not normal data. It is not non-normal. It is not normal. But after applying box cocks on the same data, what happened? I see exactly a bell-shaped curve. So before box cocks, after box cocks. Why did it work? Because MSRP contains all positive values. Prices cannot be negative. And non-normal data got converted to normal data. This is also a transformation, guys. But it's a kind of automation technique where you need not experiment yourself. If you give the values, the data to box cocks, it will try all the different possibilities for the lambda and it will give you the best fitted lambda. The best fitted lambda will be written. Now, let me explain you the code behind the plot. So plt.subplots. I would like to have two subplots, 1, 2, and the figure size, the entire figure size should be 10, 5. Width 10, height should be 5. And these we are assigning to the figure values and the axis values. So in the first plot, I want a hist plot on the original data of MSRP. By taking the original data of MSRP, I want a hist plot from Seaborn package. KD is equals to true means you'll get a kernel density plot. That curve that you see, it is because of KD is equals to true. The color should be red in color. And at which position of axis it should sit? It should sit at axis 0. At this position. This is 0. This is 1. Then, next to it, I want to set the title for this plot as MSRP original. You see the title? Yes. In the same way, using Seaborn, I want hist plot on fitted data. What type of data? I want on fitted data that was written by box cocks. KDE plot, yes, true. Color should be green in color. This will be green in color and axis will be 1, 0, 1. And This should be my title. So each and everything I have specified, and I am going to display the plot using show function. Axis, at which position you want. This represents 0, this represents 1. So you're clearly mentioning each and every specific point to the within the code. Right. So we understood box cocks. In the same way, there is one more automated technique called Yo Johnson. But before that, I'm going to print the value of lambda. For the transformation, the lambda, the fitted lambda that we got is minus 0.3171, so on. So this is the lambda value at which we got the best results for MSRP, the transformed results. In the same way, there is one more technique called Yo-Johnson transformation. It works similar to boxcocks, but it overcomes the challenge of boxcocks. That means Yo-Johnson transformation can also work on the data which contains zeros or negative values. Even if the data have negative values or zeros, whatever it might be, I can go with Yo-Johnson. Shall we understand Yo-Johnson as well? Yes. So let us import that function first of all. From feature engine, import transformation. Where did we use feature underscore engine? For outlier treatment, winsorization. You remember from feature underscore engine dot outliers, we have imported winsorizer. Right. So from this transformation that we have imported, there is a function called Yo-Johnson transformer, to which I am passing the variables as MSRP. I am just passing only one column. Let us try on MSRP. So Yo-Johnson transformer got initialized and was stored to TF. This TF, I'll make it to fit on the data, and I'll also get the transformed results. I'll get the transformed results. These transformed results will be stored to df underscore transformed. I'll show you. So you see, these are the transformed results that were being given by Yo-Johnson transformer, in which you will also have MSRP. Yes. See MSRP values, how they got transformed by using Yo-Johnson transformation. Now, on these transformed results, I'll take these transformed results on which I'm going to take only MSRP values, and I'm going to plot a QQ plot, prop plot. Let us visualize prop plot on the transformed results of MSRP. See, you see the results? How the plot is. Can you comment on the plot? Is it normal, non-normal, or what? What do you say, guys? Is it normal or non-normal? It is completely normal. It is normally distributed data. So the purpose of transformations is to convert non-normal data to normal distributed data. Okay, we have manual transformation techniques and automated transformation techniques. Manual transformation techniques that we have are reciprocal, then log, exponential, square root, square, cube, all of these come under manual techniques. In order to understand whether the data is normally distributed or not, we visualize a QQ plot, quantile plot. Yes. Apart from manual techniques, we also have Box-Cox transformation and Yo-Johnson transformation, which helps us to automate the process. Instead of doing the techniques, instead of applying the techniques manually, if you want to pass just the data and give the results, then you can go with Box-Cox or either Yo-Johnson. Box-Cox has a challenge. It cannot be, Box-Cox does not work for negative values data, but Yo-Johnson works for all types of data. I mean all types of values. Whether the data might contain zeros, negative values or whatever it might be. So this is the understanding of transformations. Why transformations are important. Clear? Yes. The next step that we have is feature scaling or feature shrinking. What is this feature scaling or feature shrinking? Why it is necessary? Let us understand, guys. Features represent what? Columns, variables. So what are we doing here? We are going to scale the features. The features that we have get scaled. The features that we have get shrinked. Why? Why should I do it? Because this particular step ensures that all the features present in the data are same. If you don't scale the features, you might have some columns with 4-digit number. You might have a column with 5-digit number. You also have a column with 1-digit number, right? So in that case, all the columns, all the features are not same. The preference will change because of values are varying, obviously the preference will change. So in order to tell all the features are same, we scale the features. That is nothing but feature scaling. Also called as feature shrinking. You are shrinking the features, the columns. Right? So in this we have three different techniques. One is called standardization. The second one is called normalization. And the third one is called robust scaling. So we'll understand. Okay. So all the three different types we'll understand, guys, one by one. I'm just importing pandas as PD for data manipulation. Then followed by we are reading the data that is present in an Excel file using read underscore Excel function from pandas, and the data gets readed to, it gets loaded to data, the variable data, the same data set, no change. What does describe function does? Describe function will return as the descriptive statistics. Will it return for all the columns? No, only for numeric columns. What all values we are going to get under the describe function? count, mean, standard deviation, minimum, maximum, Q1, Q2 and Q3. So all the 8 measures will be returned by describe function only for numeric columns. Describe function will not result for, it does not throw the results, the output for non-numeric columns. Why? How it can calculate all of these for non-numeric columns? No, right? Yes. So that means it is going to return only for 9 columns. And where are the results getting stored? The results get stored in a variable that is DES. In DES. So let me execute this and I'll open DES. You see the size 8, 9. 8 are 8 different measures. 9 represents 9 columns. What do you observe? I observe no missing value, no null values. Mean is of different. Mean is again, it's not similar to Z. Standard deviation is also big. The minimum values are different and the maximum values are also different. So that means I have to perform scaling. I have to perform scaling. There is a column called MSRP with 5 or 6 digit number. But there is engine size with just 1 digit number. Both are not same. Both are not similar. So when you try to build a model, the model gets biased towards the column which has high digit values, very large digit values. So what am I doing here? I'm accessing a part of the data. ILOC of colon represents all rows. 5 colon represents from index 5. What does index 5 means? Sixth column. 0, 1, 2, 3, 4. So fourth index represents fifth column. Index 5 represents sixth column. From sixth column, I want all the columns till last. So the data of this will be separated. Okay, will be accessed and stored to a variable data1. Where the data gets stored? To data1. So what am I doing? Separated? Yes. 428, 9. Now, let me use standardization initially. What exactly is this standardization? Standardization is a part of feature scaling. It's a technique under feature scaling which reduces the features to have mean as 0 and standard deviation as 1. For all the columns, post applying standardization, this will be the output. Mean of all the columns will be 0. Sigma, standard deviation, will be 1 for all the columns. These are the characteristics of Z distribution. But what is the formula that is used? It uses the formula of Z, x minus mu by sigma, where x represents the value, mu represents the mean of the column, sigma represents the standard deviation of the column. So this formula will be used and this will be our output. So that means, in short, each and every column will be normally distributed. Yes. So Let us import standard scalar first of all. From sklearn dot preprocessing, I am importing standard scalar, the function. It is present in sklearn dot preprocessing. Right. I'm initializing the standard scalar function that got imported, and we are storing to a variable, an object called scalar. Yes, it is done. It got imported and initialized. So to this function, I'll use the standard scalar function and I'll make to fit on the data. What is data 1? Data 1 is nothing but my data in which I have only numeric columns. In which I have only numeric columns. So the standard scalar gets fitted on the data and it returns me the transformed results. The transformed results will be stored to df underscore std. df underscore std is a type of array object. Size same. Size will be same, but the values will change. So this array object, I'll pass it to data frame function and the array will be converted to data frame. Where are we storing it? Dataset underscore std. And we'll not have the column names, guys, because from array we got the data frame, right? So that is the reason I'm passing all the 9 column names one by one. I'm just passing the list of the column names. Okay, so these column names will be adjusted to the data frame object. So they will be given as the column names for all the columns that are present in this data frame. Done. Now let me open it. See. You see how the values got scaled earlier? They are very big, right? Yes. Now you see. That is why each and every column will be similar. Now the model will not be biased towards one specific column. Then next to it, what am I doing? I am performing concatenation. I am performing concatenation, okay, where the data, within the data I am going to take the first 5 columns and the output of standard scalar. Okay, so both we are going to concatenate via columns and storing the final results to scaled underscore data underscore std. You will find the original data back, but which is scaled. Now on this data, if I perform describe function, see the output res underscore std. So if we apply standard scalar, what should be the output? For all the columns, the mean value should be 0. Is it 0? Is it 0? 0, 0, 0. Everything is 0. How come it will be 0? I see a value, right? Yes, you are able to see the value, but it is nothing but e power minus, which means 10 raised to the power minus 16, which will be something divided by 10 power 16. So 1.7 minus 1.7 divided by 10 power 16 will be minus 0.0000000, so on 17. So for all the columns, the mean value should be 0. What about the standard deviation? It should be 1. Did we achieve? Yes. We have achieved, guys. The mean for all the columns is 0. The standard deviation for all the columns is 1. So this is the output of standard scalar. What is the formula that is used? X minus mu by sigma. Where mu represents the mean, sigma represents the standard deviation of that specific column. Clear? Yes. Now let me go and explain the second technique that we have under feature scaling. It is called normalization. We understood standardization. The next technique that we have is normalization. What does this normalization does? The normalization ensures that all the columns will have the minimum value as 0 and the maximum value will be 1. So that means all the values will be between only these two values, either 0 or 1. I mean between 0 to 1. It uses the formula x minus minimum by max minus minimum. So this is the formula that it uses. X minus minimum by max minus minimum. By using this formula, it ensures that each and every column post applying normalization, the output, the minimum value in the column will be 0 and the maximum value in all the columns will be 1. Right? Yes. So I'm just importing min-max scalar to perform normalization from sklearn.preprocessing. Then I'm initializing min-max scalar. This min-max scalar I'm going to fit on the data. I'll get the transformed results. These transformed results will be stored to df underscore norm. See, it's an array object again. The maximum and the minimum. I'm converting back this array object to data frame. Dataset underscore norm. This one. And just passing the column names. Same, whatever we have done for standard scalar. In the same way we are performing for min-max scalar. Only the function is being changed. If the function changes, obviously the formula changes. Then, now I see a data frame with columns. The name of the columns. I'm concatenating the results to the original data set via columns and I'll have the output to scale underscore data underscore norm. Somewhere in the last. So on this data frame, I'm going to perform describe function. What will be the output of normalization, guys? So these are the results of normalization. If I use normalization on any data, the minimum value for all the columns should be 0. The maximum value for all the columns should be 1. Do you see the results? The minimum is 0, maximum is 1. So that is the advantage of using normalization. When I use normalization, the values will lie between only 0 and 1. Post applying normalization. Before applying, the values can be of any range. But after normalization, this will be the range. And not for just one column, for all the columns. Right. So in the same way, there is one more technique called robust scaling. There is one more technique called as robust scaling. What does this robust scaling does? What exactly does this robust scaling? When do we generally use robust scaling is, robust scaling is used when we have outliers in the data. When we have outliers in the data. So when there are extreme values in the data, we use robust scaling guys. It is robust to outliers because it uses the formula as x minus median by IQR. What is IQR? Q3 minus Q1. So this formula will be used to perform the scaling. Since there are outliers, we are also using median in the picture. Median does not get influenced by outliers, right? Yes. So we'll understand robust scaling as well. So as robust scaling uses this formula, the output of robust scaling will be median for all the columns will be 0 and IQR will be 1. IQR will be 1, median for all the columns will be 0. So let me import robust scalar first of all from sklearn.preprocessing. Sklearn is nothing but scikit-learn, okay, in which majority of the machine learning algorithms functions are available. So sklearn.preprocessing, we are importing robust scalar. Then next to it, we are going to initialize that robust scalar. The initialize function will be used to fit on the data to get the transformed results, and the transformed results will be stored to df underscore robust. See, and this is an array object, right? I'm going to convert back this array object to data frame. pd.dataframe is the function. The same code, only the function is being changed between standard scalar, min-max scalar and robust scalar. Then next to it, what am I doing? I'm just passing the column names for entire this for the data frame. I'm just passing the column names, all the 9 column names. Done. And finally, we are concatenating the results. The results of the original data and the results that we got from the robust scaling, we are going to concatenate via columns. And these results will be stored in scaled underscore data underscore robust. Yes, interquartile range. And finally, I'm going to get the describe results on the final output. Where are we storing? res underscore robust. res underscore robust. This is our output. So tell me, what will be the output of robust scaling? Median will be 0. Do we have median here? 50%. Q2. This is Q2 values, guys. Q1, Q2, Q3. Q2 for all the columns, is it 0? Yes. Then IQR should be 1. What is IQR? Q3 minus Q1. Q3 minus Q1. Let me take this first of all. 0.63 minus of minus 0.38, which will be 0.63 plus 0.38. So obviously 1. So what I can see is when you add up these values, you'll get the IQR 1. The IQR will be 1 for all the columns. Just give a try, guys. So what is our final point that we come to know? Under feature scaling, we understood three techniques. What are they? Standardization, nothing but standard scalar is a function. The second one is called normalization, where we use min-max scalar. The third one is called robust scalar. So when do we generally use all of these? To perform feature scaling. If I use standard scalar, the output will be mu becoming 0, sigma becoming 1, and the formula that it uses is x minus mu by sigma. If when I use min-max scalar, the minimum value will be 0 and the maximum value will be 1. The formula that it uses is x minus min by max minus min. And next to it, if I use robust scalar, and robust scalar is generally used on when? Robust scalar is used generally when we have outliers in the data. The output of robust scalar will be median equals to 0, IQR equals to 1. The formula it uses is x minus median by IQR. Right? Yes. So this is the overview of a detailed explanation for feature scaling. Yes. Now let us go and understand the internship that we are providing, guys. Okay. So we have already started batch 4 internship, free internship. Okay. So the demo has been completed and today it's a orientation session. So let us understand what exactly we do again. So we will have internship phases. Within our internship that Nextera Unitech provides, there are phases. Initially, today is our orientation session. Okay. So where I'll be explaining you what tools, okay, how, what we are expecting from you to do on daily basis as part of this internship journey, and how will be your learning phase. What are the changes that we have brought from this particular batch? We are going to start from today. We'll be understanding, and we also provide mentorship throughout our internship. Okay, so we'll be providing mentorship throughout this journey. You'll get guidance from the experts from our team. So our technical team is going to handle you guys, and at the last you'll be working on a hands-on project. You'll be working on a hands-on project. Now, understanding the details. This is important, guys. Yes. So initially, from tomorrow, the learning phase will start. For batch 4, the learning phase will start. What exactly are you going to learn as part of this learning phase? For 30 days, you'll have the learning phase where you'll be learning the concepts of Python, EDA, data cleansing, SQL and Power BI. So all these topics, all the fundamentals. You're going to focus on more fundamentals as part of this learning phase. What will be your daily activity? Is on daily basis, we'll be giving you some sessions where you have to go through these sessions. And for each and every session that we give, you are supposed to come up with 5 MCQs, 5 short answer questions, and 3 coding questions. So, by just listening to the session, you have to prepare 5 MCQs along with the answers, then followed by 5 short answer questions, question and answer, and 3 coding questions. Okay, so for each and every topic, at least a minimum of 13 questions is what we are expecting from your side. And are we going to evaluate your performance? Yes. 100% guys, because we are providing it for free. Right? So if you are going to take it for granted, you'll be terminated from this internship. So in order to bring a kind of seriousness, what we have done is, you'll be working on each and every session. Post understanding the session concepts, you'll be coming up with the questions. The 13 questions for each and every topic. Right? Good. So on daily basis, across this learning journey, we'll be connecting for at least 30 minutes. At least 30 minutes to max 1 hour, where you guys, our interns, will be discussing, they'll be showcasing their MCQs, short answers, coding questions and all. And our trainers, our mentors are also going to evaluate you. They'll cross check you whether you are using any kind of GPTs or any LLMs to complete your task. In order to make your task very free, you can use any LLM, right? But that's fine. We have our tracking system. Our mentors are going to evaluate your performance. And as a part of seriousness, we also going to record your attendance. At least 85% of the attendance is mandatory across this internship. And you cannot escape from the attendance. No. Until unless if it is an emergency. Assume there is an emergency at your end. Yes. Upfront. Prior tell to the administrator. Okay. You have the number, right? So you can ping us on the number or call on the number and let us know prior. Okay. So if you are going to inform about your emergency, you can go on a break and you can come back. If there is no kind of information provided, again, we are going to track your performance, your attendance. So you will be terminated. You will be removed. Okay. So that is where we have here. So guys, you have to be very serious. And on daily basis, we'll be posting the sessions. Ensure that you go through the sessions and 5 MCQs, 5 short answer questions and 3 coding questions. Question and the answer should be done by yourself from the part of the concept that you are learning from the session, and that has to be submitted at the end of the day. Okay, we are going to add all of you to a classroom, Google Classroom. You will be part of a Google Classroom and ensure that you are active in the Google Classroom. So within this classroom, you'll get all these update guys. Okay, so whatever the updates that you get with respect to the internship, you'll have it in the classroom, Google Classroom. It will be batch 4. So the registration link has been provided once again. Click on the registration link. Yes. So that is the registration link for the internship. And you can still be part of batch 4. because it is going to start from tomorrow, guys. So this is what you do in learning phase, and whatever you learn in learning phase, you are going to apply it in the project phase. So no more daily assignments. Okay, no more doubt clarification sessions. Daily basis you will be connecting, right? So there itself you are going to solve your doubts, your queries. So this is completely free, not even a single rupee you are going to pay, and the certification is also you are going to achieve. You are going to get an industry recognized certificate until unless if you don't violate any rules. Okay, and one more important point that I have failed to discuss here is if you are also again, if you don't come to the link, if you don't join the daily meetings for at least 3 days, again you will be removed directly. You will be removed directly. Okay, we'll observe, and if you are not joining the meetings for continuously 3 days, you'll be removed. Guys, keep it in mind. We are providing it for free. Not even a single rupee we are going to charge. So why are we serious about all these things is free of cost. You need not pay. If you are active, if you are showing some kind of enthusiasm, if you are learning, then obviously you can get the certificate, right? Who is going to stop you? So that is what I am telling once again. Don't take it for granted. If you are going to take it for granted, you'll not get any kind of certificate. And moreover, your learning phase, in learning phase itself, you will be terminated. So any questions related to the learning phase or the project phase? No worries, even though if you have any kind of semester exams or mid-semester exams, that's fine. You can join in the next month. Okay, we'll start a new batch in the next month. You can join that batch, my friend. Yes. Friends, the Google Classroom invite link has also been posted. Okay, just click on this classroom link. You'll be redirected to batch for classroom, Google Classroom, and you can be part of this internship, this particular batch. Yes, and finally coming to this program, Python for AI 2025. First of all, a very thank you for making the sessions very interactive, and you guys are wonderful because we have got good kind of response from your side. Because of it, we are able to do it. And moreover, the certificates, coming to the certificates, tomorrow we are going to share a message in the group regarding the registration. So be active in the groups, especially in the WhatsApp channel. We will be sharing the certificate registration link. Okay, and we'll also provide you the dates. So be active in the channels, guys. Yes, once again, thank you so much for making the sessions very interactive. And if you find that the sessions are really interesting, do share across your connections because Python is a primary skill in the market, right? So ask your friends, your connections to learn Python. And moreover, you know, if you find that if you have learned something new from these particular sessions, do share across your connections because we have taught each and every topic under the fundamentals, right? And a kind of appreciation that you can give it is a kind, just hit on the like button, guys, and do subscribe to our channel as well. Thank you so much. Yes, the feedback link has been provided. Give your valuable feedback before you leave and do share across your connections. The entire playlist is wonderful, right? So ask your connections to learn Python. The feedback link has been provided.